Hello friends, welcome to my channel. Let's have a look at problem 2543. Check if point is reachable. In this video, we're going to explain a solution based on considering the reverse motion. So this actually can be aided by matrix operations like matrix inverse and matrix multiplication. So first, I'll read through the problem statement to digest the task, and then we do the analysis, and finally we share the code. Actually, for this problem, Leetcode is marking it as hard. So the key here is the analysis. The writing the code is actually a piece of cake once we do proper analysis. First, the problem statement. So there exists an infinitely large grid. So we are currently at point 1, 1, and we would like to reach the point targetX and targetY using a finite number of steps. So in one step, we can move from point xy to any of the following points. So there are 4 points format corresponding to 4 different operations. So for example, the first one is from moving from xy to x, y minus x. In other words, the y-coordinate changed to be the difference of the y-coordinate and the x-coordinate. So similarly for the second one. The third one is amplify the x-coordinate by 2. And the fourth one is amplify the y-coordinate by 2. So the question is that, given 2 integers, target x and target y, so we would like to check if we can reach the point from the starting one, that is 1, 1. So using some number of steps, and if not, we return false. So here is an example. So in this example, we're going to return false. So actually, as a hint, you can examine 6 and 9 have a common factor, that is 3, right? So in the second example, so 4 and 7 are mutually prime. So actually, the common divisor is 1. So this is return true. Here is an explanation of the steps. So here the constraint is on the target position, so which is bounded below by 1 and bounded above by 10 to the power 9. So with that said, I guess we are ready to do the analysis. So for this analysis, if you know some mathematics, that would be very easy. So here the treatment is based on reverse motion, and we can explain this by matrix of multiplications and matrix inverse. So here I'll write the end position like using x prime, y prime. So this is a column vector. So this is the end position, it's the start position xy. So here is the corresponding m, is the corresponding matrix. So for example, the first operation, so from xy to x, y minus x corresponds to m equals 1, 0, negative 1, and 1, right? So if we want to compute the reverse motion, so we just need to multiply the m inverse in both sides of this operation format, right? So the key thing is to compute m inverse or reverse. So the reverse would be this one, 1, 0, 1, 1. So the numbers in the main diagonal does not change, and in the off diagonal it changes the signs. So this is the matrix reverse. And then you can do the multiplication for this matrix with x prime y prime. So we get x prime plus y prime. In other words, that is from x prime y prime to x prime plus y prime. So that is xy, then to x plus y. So this is the reverse operation corresponding to the first bullet item. So similarly, you can find the corresponding matrix and the other 3 reverse motions is given by m2, m3, and m4 here. So this x plus y. So here is reduce x by a factor of 2. Here is reduce y by a factor of 2. So for this problem, if we want to check if we can reach the target x and y from the 1, 1, so we just need to check if we could do this from x, capital X and capital Y to 1, 1 through the above reverse of motions, that is M1 up to M4, right? So this is much easier to analyze. So here we want to consider the GCD of the target X and Y. So I'm going to use this little x and little y with the capital ones interchangeably. So if the GCD of xy do not contain other prime factors except 2, in other words, the factors of the GCD of xy is just a power of 2, then we can reach this, achieve this task. Actually, this is also it's a sufficient and necessary condition. So actually, we can give a quick proof or argument here. So first, I want to show that. So if the GCD of xy contains other prime factors, so then we can never reach to 1, 1 from the target by the reverse motions. So assume that this is the form. So here we have a factor of 2, and then we have other primes, so where L is greater than 0, right? So this prime P is greater than 2. Then the reverse motion ending coordinates like this one, x plus y, y, and x over 2y, and x y over 2. So all of the coordinates actually can be divided by this P if we have one, right? So in other words, so it's impossible to arrive at 1, 1 because P is greater than 1, right? So this is the one direction. Another direction is that if the GCD of xy contains only the prime factor 2, and then we can do this. So here k can be 0. If k is 0, it means GCD x and y is 1, right? This is the 2 to the power 0, right? Still do not have other prime components in the GCD. So then we can achieve this task. So the reason actually is very simple. Then we can examine M3 and M4, right? So if x or y are even, we can reduce them by M3 and M4 until it contains no factors of 2. For example, in example 2, we'll explain a little bit. And then after this step, if there's no factors of 2 in both x and y, then we can use M1 or M2 according to the situation, right? So let's explain using example 2. So this is the original target position. Let's revert back to 1, 1. So here we know that so the x coordinate still contains powers of 2. Then we can use M3 to reduce this x coordinate twice. So we get 1, 7. So now at this stage, both x and y coordinates contain no factors of 2, right? So because the x coordinate is already 1, so we do not need to perform any reduce. But we want to reduce the second component. So we can use M2 in this case, right? We can use M1. So if 7 and 1 reverse, right? So you can use the M1. So if we use M1, so what we get is we get 1 and 8, right? So 8 contains factors of 2. Then we can use 3 times M4 to reduce this one to be 1. So we get 1, 1. So you actually can try this example in order to use M2. You can try xy equals 7, 4, right? Then you use reduce the y first using M4, right? And then you use M2 to get 8, 1. Then you use M3. Use M3 3 times. So actually, this here the explanation by symmetry. You can conclude this also works. So to conclude, so we can use the reverse motions to reach 1, 1 from the x and y, and so it's equivalent to see that the GCD of the target position x and y is a power of 2. In other words, so GCD of xy contains no other prime factors other than 2. So this is the analysis. So once we arrive at this step after the analysis, so writing the code is actually a piece of cake or very straightforward. So first, we can get the GCD of this targetX and targetY. Notice that I changed the name a little bit for the convenience of writing. So we can use a math GCD function and X or Y, or you can write a GCD from scratch. This is actually an easy task. You can check out some other videos in my channel which explains this. And then we just need to check if the GCD contains only a prime factor of 2. So if this is the case, so we can reduce GCD to be 1, right? So let's do this. Well, GCD modulo 2 is 0, right? So then we can do GCD interdivision by 2. So afterwards, we will just need to check if GCD equals 1 or not. If it's 1, so it means that GCD is a power of 2. Otherwise, it contains other prime factors. So overall, that's a solution format for this problem. So you can further make this code shorter, but that's not the point for this video. So with that said, let's do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here, let me comment. So overall, this problem is more is putting more weight on the analysis, especially in this video. And the analysis actually come into play are mainly about prime numbers. So in the analysis, we take the aid of matrix operations. It's just for convenience of elucidating the ideas. So with that said, I guess that's about it for this problem and for this video. You're welcome to check out other coding problem analysis and algorithms and techniques in my channel. Thank you.